Right, might as well start away. Well, thanks very much for coming along to this event done by Engineers Ireland and the GB region of Engineers Ireland. To those of you who haven't come to events before, we are the professional body for engineers in Ireland. We've got about 24,000 members. In the UK, we've got about 900, I'd say. So we are quite a sociable group as well. So after today's presentation, we'll be going to the Prince William Henry pub afterwards. Just some health and safety notices. So we aren't expecting any fire drills. So if we are, there's the door. So and you should be out in the street in no time. So just kick things off. My name is Hugh McCarthy. I'm the new chair of the GB region of Engineers Ireland, and I've got two illustrious speakers tonight who are experts in their fields in cycling and modelling, and I've also dabbled in some transport engineering in the past. So we have Mark Artis, who has worked with the likes of AECOM, Sustrans, and now Transport of London in developing cycle schemes throughout the city. And we've got John Green, who is the guy to talk to about modelling in TfL. He knows everything from Arcady all the way to Vism. And then there's myself, who's trying to keep up with the other two. So just kick things off. We've obviously live in an increasingly urbanised world, and certainly in the last over 100 years, we've gone from an urban global population of about 13% to, well, we've gone past the tipping point of 50% in 2008, and now about 54%. And then that's predicted to rise to 66%. And with the global population growing as well, we're just being asked to live in an increasingly tight space. And as you know, we quite like to move a lot. So that's where we increasingly are becoming quite important. Sorry, on keyboard. So here's the state of typical city transport in the start of the 20th century. We had about 3.5 million horses on the roads in the UK, and in Ireland we had about 500,000 officially registered horses on the road in Ireland. Not sure if they had any registration numbers, but those are the numbers. In the UK, couldn't isolate it to urban areas, but we had about 8,000 cars and about 2,000 cars in Ireland. So it's that was the case start of the century. And again, here's an example of an early London bus, and it's double decker at least, which is quite nice, but obviously limited to 8 miles an hour speed, and maintenance issues not so great. So here's Patrick Street then in Cork in 1900, and as you can see as well, it paints a very much a very easygoing city streetscape. You've got lots of horses and carriages. You've got sheep across the road as well. So again, it was a city for all sorts of livestock, and again, it was just very slow moving, complete absence of traffic lights and so on. Here's an early prototype of General Motors car, I believe, in 1900. And so it was seen as the coming thing, but not everyone was convinced, of course. This was a statement by Gottlieb Daimler, engineer and pioneer of the high-speed engine, petrol engine. So despite what some people said, by 1910, almost all London bus services were petrol engine rather than horse. Then we had the increase in trams, rail and car, just meant greater mobility. And this is quite an interesting graph if you look at it. It's the development of the Model T throughout its lifetime. So you had in 1908 when it started production, it cost about $800 and they produced, I think, 46. But by 1920, it was producing almost 1 million Model Ts, and the cost had effectively halved. So again, it was increasing cost less production. I think at one stage at its height, Ford was producing about 1,700 cars per hour. So they were very much churning them out. And here's what we had. This is the new London bus in the 1910s, where horses were almost obsolete from our roads, and increased capacity as well, increased reliance, and it was times were changing. So this is Piccadilly Circus. So streets are getting busier. Congestion increasing as well. Here's the Dublin tram as well, and admittedly not as busy, but still it completely replaced the horses as a mode of transport. Again, this is Oxford Circus as well. You can see Model Ts in Oxford Circus, getting quite busy. We also have the two London buses making a double right turn, it seems. This gentleman here you can see is actually the conductor of the entire traffic system. So it might have been the early human example of a right turn filter signal at the junction. So, there was scope for improvement. Then jumping across the water to Dublin, this is the extent of the tram system in 1916, 17, I believe. So you can see all the red lines extending out of the city. And quite ironically, this was seen as the golden age of rail in Ireland and the tram in cities. And like most golden ages, it usually signals a peak and a subsequent decline, because by the mid-1920s, the first Dublin bus was introduced. Rail was peaking at 3,500 kilometres, but was going to reduce. And it's quite interesting anecdotes at the time. You had talk of buses having greater flexibility than trams in Dublin. For example, there were stories of buses cutting in front of trams to pick up the next customers at the next stop. So it was a very highly competitive market. And increasing car usage in urban areas. I think in Britain by the end of the 1920s, we had almost 100 registered car companies production. So the times had very much changed. And then this is the typical London driving licenses as well. So you've gone from about 100,000 in 1920, gone up to 250,000 by 1930, and then just before the war, we were approaching 350,000. So again, increased car usage, central London, and road safety was what came out of this, where at some stage we had about 3 people per day getting killed on London roads. Again, you had capacity stories. I think we had 51,000 vehicles, 3,300 horse-drawn carriages, Hyde Park Corner, 1921. And of course, legislation took time to catch up with this, so we had the Ministry of Transport having to introduce road marking signs, a new concept called pedestrian crossing, which was in the Road Traffic Act 1934. And of course, we had the first traffic signals. So first traffic signal introduced 1926, Piccadilly Circus. First one they had to go at was in 1868. It was a gas-powered traffic signal. It exploded after 1 month, killing the person operating it. So had to wait another, 40, 60 years before electricity was more reliable. They had the first signal installed in Dublin in 1937. And at this stage, we now have 4,000 to 6,000 traffic signal junctions in London, depending on how you count them. So it was the scale of things. Here's a historical photo, first traffic signal in Dublin. Correspondingly, the Irish press were helpful enough to publish a user manual in the local papers on how to use signals. It'd be interesting to see if it might be worth publishing something in the Evening Standard or modern papers, just to let people know red means red and green means go. And post-war, we kind of entered the planning stage, where this is the famous Ringway scheme in London, where the plan was to build 3 or 4 concentric motorways around central London, just where the talk was purely about capacity, trying to keep things moving as much as possible. So you have the North Circular Road in the north, which is probably the only remains of that. But you also had the Blackwall Tunnel, the second bore, opening in 1967. And you can see the remnants of the M25. On the other side in Cork, you have this great separation running through the heart of the city. Now, to anyone who doesn't know what Cork looks like, I think the rail station is just to the right of the picture, but it essentially demolishing a major city block in the city centre to have multiple slip lanes. And it's worth reading about a guy called Robert Moses in New York, because that was a man who absolutely loved capacity, and at the time he was advocating lots of slip lanes and this kind of great separation in New York. And just for comparison, this is what this road looks like now. It's just a simple 3-lane carriageway, non-grade separation. So sometimes the traffic growth at the time in the early 70s was assumed to continuously be going up, and it wasn't quite the case. And by 1970s, early 1970s, we had probably the peak in road safety. So we had about 8,000 people getting killed in the roads in the UK in the late 60s. In Ireland, this is a typical trend as well, up to 1972. So something had to be done in terms of road safety. So we had seat belts became more mandatory, particularly in the early 80s. We had advertising campaigns, I think between 1970 and 1986, we had about 7 or 8 individual national advertising campaigns. So, and yeah, pedestrian crossings introduced, speed limits as well. So, I think around the time the 70-mile-an-hour limits on motorways and 20-30-mile-an-hour schemes were planned in cities in the UK and Ireland. I think drink driving is absolutely rife as well. So, consequently, we had the concept of engineering enforcement and education is introduced. So essentially it's like the police or the Gardaí in Ireland working with road safety engineers and the education of the general population on just good road safety practices. And again, this is the result where from 1970 onwards, we just had a continuous decline in road safety. And now I think Ireland is ranked 6th in road safety index in the EU, and UK is usually around 1st or 2nd. So it's something we certainly have done well in terms of our city and rural road safety schemes, and something we should be quite proud of. Then we get into the 1980s, where we had developed more sophisticated traffic signals, such as MOVA. We had the DART introduced in Dublin. So it was around the 80s when we started trying to move away from cars and actually focus more on modal shift. And then we had stricter traffic controls. We had the M50 ring road working around Dublin. So if you want to travel from, say, Ballymun in the north down to Dunleer in the south, you just use the M50 rather than go through the city centre. Corresponding in Cork, then we had the Jack Lynch Tunnel on the east side of the city. So if you want to go to Dublin again, don't have to go through the city centre. So it's creating a nicer urban environment. Then we have the Lewis light rail scheme before we had all the strikes, and this was this has been quite transformative and actually shifting modal shift from cars to people using light rail. And then in Cork, then we've had the Galway and Limerick, of course, we've had the bike share schemes being introduced, and other things like PCATs or pedestrian countdowns at traffic signals has been quite a success. And again, it's in the last 10 years, we've had about a 20% increase in cycling in Cork and Dublin. So it's quite a far-flung place from what you saw on Patrick Street in 1900. Now we have very wide pedestrianised streets, pedestrian crossings. Appreciate this isn't the brightest of pictures, but again, Cork Patrick Street, it's won multiple awards in the last couple of years for just having a good city urban environment, having less car-centric, catering to the likes of buses, cyclists and pedestrians, and just catering for the general population. And same thing in London, we've had population growing in from 1980, we've had the likes of the DLR, the M25. Transport for London itself formed in 2000, so we've had the likes of congestion charge, we've had bendy buses being removed, bar spikes reinstated, and this has just led to, again, a shift away from cars, more modal shift to the likes of cars, light rail, and again, the city centre, you'd kind of be mad to drive around the city centre now. And it's no surprise we've had an 83% increase in cycling since 2000. And then we've had the Crossrail scheduled to come in 2018. And again, this allows you to get across London in about 20 minutes, which would be excellent. So that concludes my section. This is just a quick quote by Henry Ford. I appreciate it is quite cheesy, but I feel it does sum up what our work is quite about, where a lot of our schemes we put in as traffic engineers, a lot of it is compromise, where some people might want bus lanes, some people want cycle lanes, and some people just want shared space. So it's why consultations, for example, are quite important, and we do kind of seek more the views of the public and trying to get what the population actually wants. So I'll hand you over to John Green now, who will talk a bit more about traffic modelling and what that's about, really.
Thank you.
There you go. Cheers.
Good evening, everybody. Thank you for inviting me along here. It was a pleasure. Today I'm going to give a presentation simply on microsimulation modeling. This is a presentation that I prepared previously for the team in which Hugh works, who are principally designers, and my team are principally modelers, so we thought it would be a good idea to share knowledge. I hope you enjoy the presentation as much as Hugh did originally. I'm going to start off by placing microsimulation in context of other models. There's lots of different types of modelling. They're applicable to different scenarios, different types of analysis. I'm going to have a look at why we would use microsimulation modelling. I'm going to take a little look at what VISM is and the underlying data structures and the efforts and things that it can do. The input and output data, some of its limitations, and then very briefly a couple of uses that we put the models to here at TfL. So transport models come in three broad groups, essentially. We've got, and at the bottom layer here, we've got what we call macroscopic. Macroscopic models tend to model regions. You look at transport trends across entire countries or counties. You might look at the motorway system across the entire UK as a macroscopic model. The level of detail when you get down to the road level is not great. It's more about building the links between connections and then figuring out the routes that people will take to go from A to B. This is typically what this type of modelling is all about. And it sits at, it looks like it's at the bottom, but it's the bottom of the hierarchy. It's the least detailed model that we have. They're very, very useful. We use them all the time. They kind of use a pipe flow analogy. There's no real traffic in the models. It's like water running through pipes. The pipes are our roads and the valves are junctions. They're either on or off. That's as detailed as it gets at that level. Coming further up the level, we get what we call mesoscopic modelling. Mesoscopic modelling adds a little detail to the strategic model. They're generally a little bit smaller. They can still be fairly large. They're particularly useful for town planning, new developments. They introduce driver behaviour into the model, though at a simplistic level, and they're still using deterministic equations and things to calculate capacities. These things are still inputs into the model. But they're useful. It allows us to model big areas with dynamic events and driver behaviour, maybe more detail in signal control, public transport operations, a little more finely tuned in these models. And then finally, we get up to what I'm here to talk about, now is microscopic modelling. Microscopic models, in their essence, the reason they're called microscopic is not because they're small. And we've got some extremely large microscopic models at TfL, very large, very complex. The point is they model every single individual vehicle in the network, whether that be a tram, car, a bus, a cyclist, a pedestrian. Any vehicle type we care to model, we can do. And its relationship and its interaction with all of the modes on the network will be accounted for. Distinguishing features of microsimulation models are, as I said, individual vehicles and models, cars, bikes, lorries, buses. The vehicles actually interact with their environments and each other. So you have queues will form. We'll have priority rules in the network. We'll have giveaway scenarios. We'll have bus priority. There's an interaction with the network and the vehicle on a second-by-second basis. Vehicles have driver behavior characteristics, so we can model, I mean, the behavior of drivers is very different in different cities around the world. And we can manipulate model parameters to replicate that behavior, whether it be aggressive, passive. We can do it all. This is all applied through things like desired speeds, acceleration profiles, performance of the car, a driver's attention to the environment around him. They also have what we call stochastic or random behavior. Microsimulation models are run many times in order to produce a multiple set of results. There's a random element to vehicle arrival patterns in the network. It's similar to when you may travel each day to work. You leave at the same time. You go the same route, but each day your journey might take a little longer or a little less. You might get stopped at one signal, but not another, and the next day that's reversed. This is a kind of randomness that goes on in the network every day within a narrow band. And microsimulation models are able to represent this randomness and maybe indicate network issues or things you may need to take account of very rarely happen, but if they do, they can have a serious impact on the network. A random vehicle arrival pattern could create a queue that blocks into a junction that locks up an entire network. That only has to happen once, and the design has failed. So microsimulation models are very good at looking at these types of out there scenarios. They're second-by-second simulations. In fact, they're broken down into quarter-second time steps. Every quarter second is modelled. Every vehicle movement is modelled within that quarter second. Traditional modelling doesn't do this. And finally, we've got an animation. We can present these models in 3 dimensions, nice graphics, video presentation, great for stakeholder engagement, getting the message across, talking to non-engineers, engaging with the public, letting them see what we're proposing. We can do all this in 3D animated videos, something we can't do in traditional modelling. Very quick recap. Those are the main differences between conventional models and our microsimulation models. I've gone through the points already. Individual vehicles, we've got detailed representation, queue and behaviour, because we've got the spatial element going on in our models. Vehicles have length, they have width, roads have length, they have width. Those have to match for things to work. Superior graphical output and simulation of driver behaviour. All of these things distinguish microsimulation from conventional traffic modelling. That's a view of a conventional traffic model that we use every day at TfL. Some of you probably know it. It's called Transit. It's a tool that's developed to simply coordinate traffic signals in an urban environment. So 2 junctions closely spaced together, they need to be timed in synchronization with each other in order to optimize throughput. We use this all the time. And there you see on the right is how we would represent a traffic network in this type of abstract model. And those are the kind of outputs we have to deal with and look at. It's not pretty. We find it very difficult to communicate to the general public, to each other, with designers who we just want to quickly have a look, is something working? This is not a great way of going about it. It's still an essential tool though. We still use it. It has its purpose. Oppose that to a microsimulation model where everything's visual and our data is graphically displayed in a manner that, you know, it's easily understood. You can see green times and red times of signals. Maybe not everybody will get that, but your average traffic engineer, whether he's a designer or a modeler, will understand this. We've got the 3D aspect, and we've got an abundance of different data that we can output from the model. We can analyze these scenarios in on-team ways. We really can. Why? Okay, so we've got this capability. When and why would we use it? London's busy. When networks start to get oversaturated, when they start to exceed their capacity, traditional traffic modelling breaks down. The numbers start to just get very big. They stop making any sense. Where with microsimulation modelling, we can oversaturate a network to its ultimate limit, right up until the point where it would lock up and seize. We can analyse all the way through up until that point, and we can continue to work with the model and try and find ways to solve the problem, retain equilibrium, keep people moving. We need to use microsimulation modelling when we need to apportion capacity by mode, for example, the bus network, pedestrians, cycle priority schemes, because we can model each individual vehicle at quite good detail. Microsimulation modelling is the thing to use for this type of work. We need to test complex traffic control logic. Our network is full of complexity to keep it moving, to keep it running smoothly. We need microsimulation tools to test those scenarios, to test those ideas out. They won't work in traditional traffic models. Advanced traffic management schemes such as selective vehicle detection, bus priority, variable message signing, congestion management techniques, all of this is done in microsimulation. It's a minor point there. Traditional traffic modelling works around the idea that there's a segment of time in which everything repeats. Red, green, you just go around in a circle. Traditional models, all the junctions have to match this time period that you're working with. Not so in microsimulation modelling. We can mix all types of signal control, whether it's Scoot, MOVA, VA. We can put them all in the same model and see what the result is. We might want to look at things like planned roadworks, lane closures, one-way operation. Again, we can have a look at that. And finally, the big one that's very important is for visual scrutiny of traffic scheming operation. It's a communication tool, very much so. We put a lot of data into them. I won't read all that out, but there's a lot of data to collect for these models. You're modeling each individual vehicle. There's a lot of randomness going on in the network. Data hungry, time intensive. You can go on, depending on what type of studies you're doing, you might want to go into pedestrian occupants, bus passenger occupancies, pedestrian flows, all sorts of things. The tools are constantly in development, so this list is likely to grow as we move forward and see different types of schemes. Okay, we use a software package called Vism. It's not the only microsimulation tool available on the market. We use Vism. We also use another tool called AimSun. Just happens to be a Vism presentation. They're both equal to each other. They can both do the same type of job. We have a lot more capability in Vism because we've been using it for such a long time. And we physically, on a computer, build the layers of road networks as they would appear to you. So we're not abstracting in the same way as we do with traditional tools where you've got links and nodes and this abstraction away from what's really going on. We actually build the physical network as you would see it out on site. And we use these lots of links and connectors, and it's quite a fiddly job sometimes, but it's worth the effort. And every one of these links and connectors in that network can have our parameters that can influence driver behavior. So we can coerce drivers to do what we observe them to do on site, whether that be speeding, giving way to pedestrians, being aggressive, merging, overtaking in the same lane, lots and lots and lots of good things. So it gives a lot of great flexibility. We normally start with a well-made design engineering drawing here. This is Parliament Square, and this is one of the designs that was proposed for the East-West Cycle Superhighway routes. It's quite a complex design. It's a very complex layout. I don't believe, as far as signal timings are concerned, we could use something like transit to come up with a reasonable set of signal timings. But to really understand how this thing is going to work, how pedestrians, their cyclists and their vehicles are all going to interact in this design, we have to go to a Vism microsimulation model. And we quite literally just build our network on top of this drawing. Every element of the network is in there, whether it be a stop line, a bus stop, a loading bay, cycle lane. It's all there. All the signal control is in the model, all the staging, observed traffic flows. We're using the same road space that's being apportioned on site in the model, so we can look at spatial issues such as queue lengths, overtaking behavior. It's all in there. You can see the different colours are referring to different types of things. Orange is for pedestrian movements, the green links are for the proposed cycleways, the grey links are general traffic roads. I'm good for time.
Yeah, perfect.
Bit of a fancy slide there. The microsimulation models do very complex mathematical calculations in order to emulate driver behavior. The picture's actually from a PTV manual, which their help manual that tries to describe to you how this model is working. I don't actually find that very helpful. Working with the model is much better. Microsimulation models, because they're so visual, you spend most of your time watching a network, calibrating it, adjusting parameters, and observing that you get the result that you're looking for. You don't need to refer back to deep mathematical equations again. It's not necessary. Vehicles, I've said we can do all vehicles in a model, and I really mean we can invent vehicles if you wanted us to. We group them together in a number of ways, and that depends on whether we're grouping them together on size, their performance, their purpose, or their applicability to highway regulations. You can see there that all of that data displayed there on that screen is, loosely speaking, a small segment of the data that I would apply to a cyclist in the model. And we have to do this for all vehicle types in the network. And then we might even split our vehicle types up into different classes of types, so aggressive cars, non-aggressive cars, things like that. Commuter cyclists, leisure cyclists. we model all those individuals by adjusting parameters in the model. Outputs, numerous. We can look at everything: volumes, speeds, mean speed, detailed travel times and delays, turning counts, queue length statistics. If you can measure it on street, you can probably measure it in a Vissim model or a microsimulation model. It's trying to replicate it in the same manner. You can cover any amount of simulated time, and it can be specific down to an individual vehicle, if you like. You can track individual vehicles from the network and get full journey time, delay, statistics, everything. We also get programmatic access to microsimulation models. So those of us that can write VBA software code, we can interact with the model and bring out data in a manner that we need, even if it's not native to the model itself. And naturally, 3D visualizations of the network for stakeholder engagement. Okay. They are still limited. I've mentioned that at the beginning that there was multiple layers of modeling and some of the more traditional tools. Microsimulation models don't generally optimize signal timings in the model. We have to find an optimized signal timing plan, put that into the microsimulation model and test it. We can do some fine tuning at that stage, a bit of tweaking on the timings, but actually getting an optimized timing plan is difficult and hard work. So we use transit and SIG models to feed the Vissim models or any of the microsimulation models. They don't tell us how a scheme or any scheme will impact on travel demand. They assume the origin destination matrix and traffic flows loaded onto the existing network will not change. Now this is where we go back to the beginning, and I talked about strategic modelling. Strategic models are suited for exactly that. They look at the demand for travel. They figure out how people are going to get from A to B. If I've got a Vissim model in which our intervention is significant enough to change traffic flows and demand, I would have to go back to a strategic model, do some analysis there, and apply new flows and routes in the Vissim model. So although it's a limitation, it's not something we can't handle. We can still deal with it. Just have to do a little bit more work. Yeah. Other things, so we still on conventional models, we still start with designs. We still use things like LinSig to maybe come up with a signal control design. So we wouldn't do that in a Vissim model. Again, the signal operation is designed outside. We bring that into Vissim, where we can fine tune naturally, but it would be hard work to design in Vissim. We take all of that data, we put it into Vissim, and we get scheme implementation. So we still are reliant on other tools. The point I'm making is Vissim, or I'm trying to make Vissim or microsimulation sound super great. It doesn't work on its own. It still needs support. Okay, I'm just going to end now with a brief, very brief, on what we've been doing at TfL recently. I've been working for the last 2 years now on a business case called modelling capability. The goal of that business case was to build a large strategic model that covers all of London. And that's named the One Model. This is our strategic model that looks at travel patterns, movements throughout the entire network, and how those patterns and travel times and delays might change given our intervention. So that's a very valuable tool in our team at the moment. Another part of that was to develop the entire 23 TLRN corridors in microsimulation modelling. I can't emphasise the scale of that task. Every major road coming in from the M25 into central London, including the orbital routes like the Inner Ring Road, the Outer Ring Road, North Circular I should say, and the South Circular, all modelled in microsimulation in their entirety from end to end. They generally run for about 2 hours. We've just got to the stage where we've completed that work. The first aspect of our modelling capability programme was to develop London in 3D. So now we can present the microsimulation work in a 3D environment to our stakeholders. It gets schemes built, it saves time. A lot of time is lost in scheme development through trying to communicate engineering to people. Very quickly, we've built all of the corridor models now for the 23 TLRN corridors, I should say. Collectively, I mean, we built this schematic, we copied the tube map to show all of the corridors in London, and we've built all of that in microsimulation modelling. Just a few stats to give you a sense of scale. Collectively, because each corridor is an individual model, collectively 4,000 London bus routes, calibrated and validated against observed data, 4,300 signalised junctions. We cover over 950 kilometres of road space, and we're simulating collectively around about 98 hours of urban traffic control operation. We've had to develop a process for this over the 2 years. We've got methodology that just for building large-scale microsimulation models. The tools are aimed at keeping things consistent, removing errors, removing the manual input of data that you don't need a professional modeler to do that. We wanted to focus our time on, once we've got the model put together and arranged and the data in there, we want to calibrate these models and get them representative of the network. And this process, this whole thing was developed in order to allow us to focus on that aspect. The methodology is in constant review. We're always updating it. Almost done. What do we do with the corridor models? One of the principal pieces of work we do is journey time reliability analysis. It's a KPI for us. We are tasked by the mayor to maintain and improve journey time reliability along our key TLRN routes. We need detailed data output from a model that describes the journey of every individual vehicle we modelled. Microsimulation is the only type of modelling we can do this for. We also have we've got urban traffic control system running across London. We've also duplicated it onto a PC-based version of it, which we can connect to our VISIM models. So our VISIM corridor models are actually talking to the exact same urban traffic control system that our real junctions and signals outside are talking to. It's a replica, it's offline, so don't worry, we're never going to get them mixed up. But it shows we've got Scoot in there, we've got Nova, we've got V8, we've got SAS, iBus priority, we've got it all, demand dependency. Everything that's out on our network is now in our VISIM models. This is quite special. I don't think there's anybody else, I don't know of anywhere else that's done this. Really done. We've got all this data, all these models. What do we do with them? We don't just leave them on a file somewhere. We've recently developed a modeling library, which collects a lot of metadata. We relate to search. We can apply security, archiving. It's accessible through web browsers and file explorers. My team manages this side of the modeling library to get everything recorded. There is then another tool which we call Playbook, which can talk to our modelling library and give users across London, the boroughs, TfL itself, a view of our modelling library stock, what models we have, why they exist, what we should be doing with them, etc. And that's it from me. If there's any questions, I'd like to answer. Yes?
Two questions.
Yes, okay.
First is about technological.
Excuse me?
Technical or engineering question. I believe there is some storage drivers or storage cycles which has got a singular or odd movement on the node or kind of the pedestrian area.
Yeah.
But the detection system in the London is already detecting such kind of the storage moving people or drivers.
Yeah, I mean,
It is included in the kind of system simulation.
it depends. We can attempt to replicate all behaviours on the network, but I think that would be a little beyond us. You know, we can attempt to replicate everything that we observe on the network, but you have to draw the line somewhere. You have to say, right, what is it important that we're seeing this, and if it is, we will endeavour to implement it in the model. But what we have to do first is we need to get some data on it. We need data first before we can build the model. So how do we describe that phenomena in data? How do I put that into the model? If I can do that, then yes, we'll do it.
So if you are detecting the movement of the vehicle, for example,
Yeah.
the individual vehicle, majority of vehicle is maybe moving smoothly, but you also be detecting the strangely moving very fast, very slow area big plasma.
Yeah, on the network that's happening. In the microsimulation model, it might be a bit smoother, it might not be as erratic, but we can do that. If we feel it's necessary, we can replicate those scenarios in microsimulation.
The actually question is usually we go to the Google map, and then I can find the best route from here to the kind of my home hotel.
Yeah.
And then sometimes it shows the kind of congested area or direct area or the construction areas.
Yes.
So what is the difference between such a available Google map and the other consistent transport?
Okay, Google Maps may be doing a very good job at telling you what's happening now, but it's not going to tell you anything about what's going to happen next week or next year when you've developed a traffic scale that you're going to put in on the network. That's the key here. We replicate the network as it is in order to predict the future network. We don't currently use our models for real-time analysis. However, that is going to change. There will be real-time modeling soon in the future. We're working towards it. We will have online, real-time running traffic models, replicating the events out on the street and predicting what's going to happen in 30 minutes and responding to it within 5. That will be coming in the future.
So what is the essence for how you can predict the future? Is it a statistical data?
I don't know the deep detail of it. I know it's cool. Anybody else? Yes.
Yes, and some bus stops have been extended in London recently,
Yeah.
and some of them overlap access ways.
Yeah.
Could you clarify the situation with the conflict? There appears to be a conflict here.
When it comes to, probably the designers are better to talk to than me as the modeler. I take what I can give and I model it and I give you a result. I agree, it sounds odd, but I don't know anything about this. And I'm not really involved in policy as such, so it's totally out of my area, sorry. But we could model it. We could put it in a traffic model and see what the impact is if we have the data.
Yeah, last question. Is there any further work is going on towards modeling the shared surface correctly?
Yeah, absolutely. Shared space modeling is something that's becoming more and more pertinent to the work we do here, especially when you start looking at the cycle schemes going through London. There's a lot of shared space scenarios going on in that. I will be honest, shared space modeling is very, very difficult in any modeling package, I suppose the closest thing to it is the social force model, which currently is being applied to pedestrians. We are engaged with our with our suppliers. They're aware of our needs, but these aren't easy things to solve. It's going to take time, but we're making the effort. We're doing what we can. So yeah, I imagine it's on the horizon. We will have it eventually.
Just my point. Are we talking about something like Exhibition Road?
Yeah, Exhibition Road is a good example.
Okay, well,
Thank you.
Thanks,
Cheers.
Hello everybody, can you hear me at the back? Good. There's no microphone, so if I do talk lighter, then let me know. My name's Mark Artis, and I'm a lead design engineer here at Transport for London. But this is a personal presentation, so please don't take anything I say as TFL's viewpoint, it's more mine. So that's the disclaimer out of the way. You probably get a flavour of what I'm going to start saying now. I'm going to do a little bit of an introduction about myself, talk about some of the stuff I've worked on in the past, some of the present stuff we're working on at TFL, a little bit about the future and innovative ideas, perhaps, and then I'll pause at the end for some questions. Hugh said introduce a little bit of humour, so here's the humour. The bottom one's particularly good. Anyway, I've got 10 years of experience as a traffic engineer. I'm a member of the IHT, and I've worked across multiple organisations. So I've worked in consultancy with Sustrans, a cycling walking charity, and now at Transport for London. And I'm a bit of a keen cyclist myself, so I have a vested interest in the stuff I kind of do. The picture of me at the top is me doing some engineering. I think that was measuring the height of curbs for bus stops. Yeah. So I'll start talking about some stuff that I've done in the past. So my career's currently overlapped with the development of cycle superhighways and the kind of move towards the Mayor's vision for cycling in London and where we go in the future. So I feel like it's kind of defined what I've done so far. And the first thing I really worked on was cycle superhighways Route 8. It's kind of the forgotten superhighway, if we can call it a superhighway. It was the first generation, but that means the first one after the pilot. So the pilot routes 2 and 7 were where things were tested, and then 3 and 8 were the ones where we actually implemented some stuff. Now, I quite like Route 8 because I worked on it, but there's some good bits and bad bits of it. But essentially, it's 7.5 kilometres of blue paint with some novelty features in there. But it was a really good stab at trying to parcel up parts of London and get a cycle route along a potential commuter route into, well, hopefully, it was meant to go to Parliament Square, so it stopped short at Lambeth Bridge. But it served its purpose at the time, and it was kind of groundbreaking for then. There's some good parts of Route 8, and one of them is Wandsworth Bridge roundabout. So this was 6 circulatory lanes. If anyone's familiar with that area, it's a very busy, horrible roundabout, and the routing was to go basically through it. The line on the map, the alignment was through the roundabout. As you can see, there's some kind of substandard segregated cycle facilities there, and a subway, and very intimidating traffic conditions on the carriageway. And actually what we did, this is back in 2011, we took a lane out from quite a busy road on the TLRN and put it to 2-way cycle track. So the seeds were there for the stuff that we're doing outside and on the embankment and on CS2 upgrades. So that is only about, 30 metres long, but there was some segregated 2-way cycle track back in 2011. So that's five years ago. And it's very blue as well. Now, Milbank was a particularly difficult junction, and I know if you look at the after picture now, it doesn't really look that good. It doesn't have a hold the left turn, doesn't have all these new features that we're doing on CS2 upgrade, for example. But at the time, actually getting the blue paint on the ground and putting lanes across junctions and highlighting that the presence of cyclists was quite a big deal. And the 2 elements north of the river, so we come across at Chelsea Bridge, so along Grosvenor Road and Milbank towards Lambeth Bridge, there's some actual vast tracts of lanes, not segregated, mandatory cycle lanes that are quite wide with flow and very vivid blue when they were first put in. And that's pretty good in my book. I mean, I wouldn't want to segregate that then or now. It's quite well respected as a cycle facility, and I do know that Route 8 is being upgraded in the near future, I believe. So that might change, but in my opinion, we did some good stuff back then. A real problem that I found when working on Route 8 was how we dealt with curbside activity. It's much to do with the alignment of Route 8 in that it goes through a couple of high streets. So it goes along Battersea Park Road and Battersea High Street. So there was always going to be an overlap with loading, parking, curbside activities. And here we can see in this photo, thank you Google Street View, that it was simply put some paint through a loading box and just hope there was nothing in there at the time. So if the loading box works and it's only used off peak, then during the peak times it should be free. But we've had a step change now, and granted, Whitechapel Road is a different environment, it's a bit wider, we've got more space there, but it's a similar scenario where there's a bus lane, there's a loading bay, and there's a cycle route. But what's happened now is that we're segregating, and we're thinking about how loading activities will happen across a cycle track. So here you can see we've got some gaps in the segregation, so you can access the loading box quite easily, and then a drop curb up onto the footway, but all the while ensuring that it's an undisrupted movement for cyclists. It's about taking them out of the danger zone, I suppose. So that was a bit of history, that was a bit in the past, and that was around the end of the noughties, and then turn of the decade, well, a bit later than that, we had Mayor's Vision for Cycling in London, so that's really up the game. And interesting document that has come out actually is called Human Streets, which is it's a GLA document talking about the impact of Mayor's Vision for Cycling in London. So I think Forest does have some cause of celebration on that. That's quite a useful document, Human Streets, and that'll give you a pitted history of perhaps why Quiet Ways hasn't worked quite as well as the cycle superhighways, for example. So the plan when the Mayor's Vision for Cycling was to improve overall connectivity throughout the whole of Greater London by including new cycle superhighways, establishing a Quiet Ways network, and then in the core, in the centre, creating a dense central London grid. And then to really enhance some of the outer London boroughs was to include mini Hollands in this overall strategy. Those mini Holland boroughs are Kingston, Waltham Forest and Enfield, and in my team we've been working on the Enfield project. But this map here shows the kind of density that is the aim for the central London grid eventually. That includes the blue lines are cycle superhighways and the purple lines are Quiet Way-esque grid routes. But I suppose that the real challenge for me and my team, in that with the step change came new cycle design standards and also new specific design outcomes. So the goalposts have moved a little bit and the sites were set a little bit higher. So with the Quiet Ways and grid, for example, we've had to try and adhere to this set of guidance that's shown on screen as much as possible. And if we have a departure away from that, then we have to justify it. So this set of criteria, for example, plays on the 5 or 6 concepts that are kind of underlie through the LCDS. And to give you a flavour, there's trigger points on vehicles per hour. So over 800 vehicles per hour in a two-way flow, there should be a greater degree of separation for cyclists. So it actually, for a change, it gave us a qualified set of criteria to work to and then justify against. It's actually helped to shape certain schemes and then try and argue the point when it comes to politicians. I'm going to run through a few schemes that we've been working on the grid and Quiet Ways. Apologies, all the images are consultation drawings, so they're in the public domain, so there will be no design drawings shown, but you'll get the idea, and you can talk to me afterwards if you want to know a bit more detail. So Goswell Triangle on Quiet Way 1 up in Angel, I'm led to believe this is the busiest cycle crossing in London, in that it has 1,300 cyclists heading in one direction in the AM peak, and then about 1,000 in the PM peak coming back. So it's very tidal, but it's incredibly busy. And before, granted there was a housing development there and a large hoarding, but it was quite cramped. If you check out where the curb line goes through the stats covers, that was a really narrow, probably about 2.5 metre wide facility, and it couldn't even, it's meant to be two-way, and it couldn't even take the numbers that were there in that day. But what we've done it doesn't look like much, but if you look at the curb line now, we've moved that out 1 metre, and everyone's sticking in there with flow lane. So if you work in the other direction, you've got a chance to get past them now. So it's these small little things that we've done that hopefully will make cyclists feel that they're part of the network, the fabric of what we're working on. And within Goswell as well, we've put in low-level signals. So if you can imagine on the before picture, when you got to the stop line, you'd be looking up, or you'd be looking at the secondary signal to try and make you aware when the signals are going. And if you're at the very front and you're looking up, then it's not very pleasant. So this little thing like putting low-level signals in, so they're at your eye line, and it's quite a simple thing to do, albeit a little bit expensive. And then on the other side of the junction, or the other side of the triangle, there were no cyclists there at all, and then after there were loads. So no, that's not the greatest before picture. It was very busy. It had 1,300 cyclists going there and now, but you can see there the space is really constrained with a curved island. We've got a hoop on the island. Road markings not leading anyone anywhere. So what we've done is we've tidied it up. It's a simple thing about how are cyclists using the space. So what we've done is we've taken the island down, made it flush, and taken the bollard off and opened that space up so more people can use it, but there's still an element of the contraflow existing. I've got a little time-lapse video, which, let's see if this works. Yeah, see? So very busy, but people moving that island means that people can filter around. They can move around the cars that may be encroaching in the SL, may not be, but it's just the little things like that that make that space available to use. So you can see that they're actually starting to wait on the island, whereas before they might have been constrained in there. iPhones are wonderful. Right. I don't know if anyone knows the scheme, but it's been causing me a headache for 2 years. Yeah, 2 years. This is on the inner ring road, which is TLRN, and it's circulatory to central London. Once you come in off that, you're in the congestion charge zone, and it carries a lot of traffic around the core of London. So we've got to keep London moving. So any pressures, there's loads of pressures on here, and we have to ensure that journey time reliability isn't affected. So this junction here was open to quite a lot of scrutiny because it's an offset junction. You can see on the proposal below, the side roads are slightly offset. So we're coming down this road here, Rothsay Street, and we want to go down Webb Street. And it's not a simple straight across junction. It's not a crossroad, it's slightly offset, which always causes us problems. So the initial thoughts were, let's put in a signalised junction, let's put a stop line up here, put a stop line down here, and then just have the side roads for cyclists only coming out, and that's it, simple. The problem was, we lost 4 seconds per cycle from changing it from pedestrian crossing to a junction. And if you multiply that over an hour, it meant that we would have to put in a few more bus services, which would mean a few £100,000, and it starts to snowball. The cost of your scheme then doesn't become viable. So then we started looking at actually using a crossing of the road rather than a signalised junction. A toucan crossing was mooted, but dismissed quite readily by powers above me. I think the toucan crossing gets a fairly hard rap, actually. It serves a good purpose. And somewhere like this, it makes quite common sense, because where you've got an offset, you might, if you can't get a signalised junction, you're probably likely to want cyclists and pedestrians to share some space. And the token crossing allows a cyclist to enter an area and then wait curbside next to the push button and then proceed across. It's kind of a conventional layout. Okay, it's not dedicated space for cyclists, but it kind of solves this offset junction problem quite well. But what we actually came up with was this parallel crossing where cyclists have their own dedicated crossing area. So you can see on the proposal, on the consultation plan, that's highlighted by the elephant's footprint. So they have their own stop line that's associated with a push button or detection, and they have their own low-level, high-level signals. The problem with this location is they have to interact with pedestrians on the corner. So if these junctions, if these side roads were lined up perfectly, then a parallel will be easy. It's just in this location we've had to compromise, and it results in an awkward movement. But if you do go on Quiet Way 1, go down there and have a look, because it's actually, depending on what time of day, it's quite easy to navigate. It doesn't look quite as complicated as it has got a bit of a rap for. A few more elements we have been kind of using on the Quiet Ways. Quiet Ways and grid intersections are trying to be less big. That's not probably a good word for it, but less disruptive and less. It's meant to be kind of like small interventions. So one of the ways we can do that is to offer a bit more in space and time for cyclists. So the early release is aimed at cyclists in an ASL having a head start over the traffic behind them. Typically 3, 4 or 5 seconds depending on the layout. Here in Finsbury we've done, I can't remember how many seconds, but we've put in early releases on the 2 side roads shown in the picture. That's Calthorpe and Marjorie Street, so this is on the Quiet Way alignment. And that gives cyclists a bit of a head start over left-turning traffic, for example. The problem I've found with early release is once it's in, on a plan, it's in, and it's in 24/7. So you've got to be quite confident that you want it and that there's enough capacity in the junction to take it. Fortunately, at this one, we were okay, but often, if you're looking for space, looking for capacity issues and trying to resolve them, taking the early release off might give you that extra few seconds back. But then you are left with, if you put in large ASLs for large numbers, then you've still got your in-space separation, so they get a head start over traffic that way. But these are the kind of compromises we've had to come up with for certain locations. The 2-stage right turn and left turn, we've put them in on a few Quiet Way junctions, or we are proposing. This is a CGI model of the junction outside, actually, and there's a YouTube clip associated with that, but I won't do that now because it's a TfL branded thing and it's a bit dry. But but essentially, it allows cyclists to make the movement onto our Quiet Ways or grid without having to do a right turn or left turn within the traffic, within the carriageway. So this example shows a segregated cycle track, and you could access the 2-stage right turn from that. But in many instances that we're doing, you may be on the main road with traffic, but then you're provided with a little pocket to turn, do a slight left, and then line yourself up, look at a far-sided signal, and then proceed ahead and at the next available stage. A lesson I've learned is that where you are doing 2-stage right turns or lefts, it's important that the following stage is the side arm. So in this example, the arm at the top, so that cyclists aren't waiting there too long or they become impatient. If that's possible, you can move staging around, then it means that you will turn off, you'll wait, and then you'll go next, rather than having to wait maybe half a cycle or wait for the peds to go. And that's the danger, is if your next stage is pedestrians, then cyclists just go. It becomes a bit of a scramble. So if you do 2-stage right turns, then try and, if you can, move your staging around. We've also had the opportunity to work with boroughs on non-TLRN schemes. And that's given us a bit of a liberty to push the design envelope a bit further. So this junction is Portland Street, Albany Road in, I suppose it's near Woolworth Road, just southeast of Elephant and Castle. And it's part of Quiteway 7. And it's not a strategic road network, it's not transport from the road network, so it's just a borough road where there's a lot of inefficient use of green time, there's lots of wasted green time, quite a long cycle time, and lots of time in the junction that nothing really happens. So we were asked to come up with, trying to provide something that's quite pushes the envelope on providing segregated facilities at the junction. So we've come up with cycle bypasses, we've got dedicated cycle stop lines, we've got straight across pedestrian crossings, removing all the staggers, and we've been able to model this and make it work more efficiently and get a reasonable cycle time of about 70-80 seconds. So cyclists are only waiting about a minute for their dedicated signal, which previously, on a much longer cycle time, they were waiting for quite a long time and they were just going in the pedestrian stage. So a lot of what we do is trying to get in the mind of a cyclist, and are they going to wait at a facility? So you might have the best, this might be the best facility in the world, but if you've got to wait 2 minutes to use it, then inevitably you're just going to cycle through it. So this kind of demonstrates a bit of a balance and how we've managed to put that kind of stuff in by looking at Lindsay modelling as well. But some of the best stuff we've done hasn't really involved any of these new techniques. It's just about changing road layouts. So stuff like making roads one way in with a contraflow cycle lane, removing the two-way element of that side road, for example. So this is in Westminster, it's off Edgware Road. There's a crossing going southwest to northeast, and we were asked to provide a decent cycle crossing, high level provision. So we've made it entry only and put a contraflow cycle lane in. And only by having the kind of like the kudos of doing it on the back of the grid and quiet ways could we ever envisage doing something like this. Westminster, dare I say, probably wouldn't even dream about this unless there was a grid alignment going across it. And similarly on Midland Road, Judd Street up in Euston, next to King's Cross, St Pancras Station. Midland Road is currently 4 lanes of traffic, southbound only, so the top of the picture, southbound only. And we're looking to take some of that space and make it cycle only, so you have a contraflow cycle lane and a with flow cycle lane. And similarly on the other side of the street, potentially closing it up completely. So these are not revolutionary techniques, they're just using age-old engineering techniques and then just rebranding them. And then Marylebone Road, Harewood Avenue, another one on Westminster's patch, where Harewood Avenue, the top road in the picture, was actually two-way, and the proposal is to ban a left turn, close it up and replace it with a contraflow cycle lane. So pretty bold stuff, but it doesn't have to be that innovative or revolutionary. So that leads me on to innovation, and it's quite an awkward word, I find, because innovation, we've probably got most of the powers to do stuff now, it's just doing it in a different way. It's like kind of the engineering techniques are maybe already there, it's just ensuring that we can put them in at the right place at the right time. So stuff like cycle-friendly radius on a junction on a central island, you can see quite a sweeping radius there to allow cyclists to turn right from the main carriageway, whereas before you might have just put a very tight radius on that corner. We've kind of left it out a bit to enable cyclists to move a bit easier. And then crucially, materials and making sure things look nice. Quiteway 1's kind of, if you go along Quiteway 1, they've really gone for it. It's cycle turfing, I think the terminology was, where everything's block paved, kind of lined in gold. Marshalls did really well out of that, I think. Looks really good. Some of it's starting to fail, but material is important. So do you need block paving, or is an asphalt top table good enough? Okay, you've got streetscape to consider, but material selection is all important, and the new TSRGD gives us new opportunities in terms of what's now legal. So the parallel zebra crossing is now legal. We can take away those giveaway lines, and you'll be seeing a couple of these come in on TLRN, dare I say, in the future. It's controversial. So in summary, I think cycling in London's all about evolving design. I wouldn't want to say it's been a revolution. We've always had the tools there. We've just kind of added a few new features. The strategic view of your client or organisation to say where routes go and to try and make them not go in very awkward positions across very complex junctions also helps. And of course the devil is in the detail, and a lesson learned is politicians and sponsor reviews, for example, the devil is in the detail. They want to know what it's going to look like and how it's going to feel, and the earlier you can tell them that, the better and easier it becomes. So, any questions? Good, let's go.
Ask you about interaction with pedestrians.
Yes.
Because the most dangerous thing that I encounter on a daily basis is cyclists going straight across junctions, zebra crossings, completely oblivious to the rest of the world, and without lights at night. How are you going to? I mean, they are possibly the most dangerous thing I find. How are we going to encourage in the cyclists a sense of responsibility? And also, they have no audible warning very often. What are you going to do about that?
What would I do about that? I don't know what TfL are doing about that, but a lot of it is education and behavioural. Most of that kind of stuff may come from frustration about how junctions are signalled and the way the anticipated wasted time you've got in a junction, for example, or the routing's not quite right, so I'm going to take a shortcut across this area and come into conflict with pedestrians. So it's fundamentally behaviouralist, but then if you can get the engineering side right and the layouts right, you might encourage better compliance. We're kind of working on that, and we're trying to move away from mixing peds and cycles as much as we can, but inevitably it's going to happen. It's going to happen in some places.
Are there statistics about accidents for pedestrians by cyclists? Are they listed separately?
They'll be available. Yeah, I don't know numbers, but yeah.
So collisions between pedestrians and cyclists. Is that what you're on about?
Yeah.
Yeah, they are there.
Do you have a number available?
Not a massive abundance of them from what I've seen, but again, it might change as volumes increase.
People who died from heart attacks who've just been missed by cyclists, they didn't turn out with that.
Yeah.
Well, yeah, there's the near miss as well. It's
Plenty of those, anyway.
Yeah.
See those all day long.
Yeah. I haven't got a solution for that.
I think just on a question about the cycle grid and that it's kind of a lot lesser known than the site superhighways.
Yes.
Have you found it's easier to implement or get under less scrutiny than say a site superhighway?
So, yeah, that's a very good point actually. The cycle superhighways have been quite straightforward to implement, I would suggest, compared to the grid and quietways. I think if that Human Streets document kind of nails it on the head when it says the sticking point with quietways and grid is boroughs, and it's an extra layer of stakeholder involvement. So where the TLRN is essentially TfL's network and they can do what they want on it, as soon as you go into the realms of boroughs, you've got an extra layer. You may be able to promise them money to do stuff, but it's still having the political will, the councillors, local stakeholders to influence positively about cycling. So yeah, it's made it. I think that's why the quietways and grid have had less publicity in the last, say, 3 months, 4 months. You've only seen 2 quietways open, and it should have been 4 to 6. So that, yeah, you're right. That's in summary, that's what the difference is.
I've seen quite a bit of ASL in your own designs, and I think ASL is one of the most difficult things that we are facing as a designer when we do the design. Like one of the examples that you've shown, where you showed the video where a lot of cyclists are using and informally all the areas. One of the areas I'm seeing the cyclists are coming from the offside, they're actually crossing the white line to get into the ASL.
Yeah.
In this kind of situation, what you look at after when you design, this is something not legal, but still people are doing it.
Yeah, in that example, there's an offside feed lane because it was left turn out only. So the feed lane was on the offside of the vehicle. So the number of cyclists there is enormous. So they always spill over, and they become the dominant form of transport on that road. The car is second, definitely, in that location. But yeah, overall, access to ASLs is quite a big thing. So you can put in early releases and you can have all these new features and say you're going to put a massive ASL in. But if you can't get to it and you encourage the cyclist to move into a conflict zone, then you've got to question why.
The whole philosophy of using the ASL is also changing now. We're thinking of introducing a gate for ASL, increasing ASL storage area to 18 meters, so things like that, which is going to look very different.
Yeah, I mean, it's easy to just go to a junction, plaster it with ASLs and early releases and low-level signals. It's quite easy to do that, and that's potentially what a lot of boroughs have done. But when you come down to it, you've got to analyse if you really need those features.
Probably that's the easiest thing to do initially as a cycle improvement. That's why people put it out.
Yeah, it looks obvious that you've done something, but you might not have done it in.
That's not list condition creating kind of scheme that you probably have.
Yeah.
Otherwise, if you put a cycle gate, it will create lots of condition.
Yeah, but it's all site specific. Yeah.
Any more questions? Oh, never mind.
Thank you.
Thanks so much, Mark.
So I just get a round of applause to Mark and John.
And you.